Hello and welcome to this lesson on application layering and loose coupling between different layers of an application. Whenever we develop any kind of an application, we would see that our application will have different concerns or different dimensions or different aspects to be addressed. So first we need to find a way to represent data of our business domain in some form. In Java applications, this data representation is done using a simple set of plain Java classes, or POJOs would be written to represent data. Plus, we also need to write the logic to load and store data from some form of permanent storage, such as an RDBMS or a NoSQL database or from a file system and so on. We also would have the core business logic of the application. This business logic concerns the business domain, and this business logic would be independent of the type of logic used or the type of storage used. In addition to that, our application would have possibly a user interface as well. This could be a web-based user interface. This could be a mobile user interface. It could be a desktop user interface. That could really vary. So the idea here is, rather than write code which has all these different types of logic intertwined, therefore making it very complex to maintain and evolve, we would like to separate these concerns. So this is what we call separation of concerns, driven by a software design principle called single responsibility principle, or SRP. So going by this principle, what we would like to do is we would like to create a set of classes which concern with data representation only. That's one concern. Similarly, we would write another set of classes which deal with data access only. That's a separate concern. And we would write another set of classes which deal with business logic only. We separate that concern out. And possibly different groups of classes to do different types of UI. So these different groups of classes that we write is what we refer to as different layers in an application. So we would like to have different layers in an application, each layer responsible for a separate concern. The idea could be that not only it helps us maintain and evolve the application, it also makes it significantly easier to independently test and independently reuse and independently replace different layers or different modules. Probably, what if I wanted to replace the existing RDBMS based data access and replace it with, let's say, MongoDB, but I want to keep everything else the same. So I should be able to just independently plug out an existing class and plug in a new class. So that's the idea behind, or that's the need for layering of an application. And not only we need to separate the application's code into different layers to deal with different concerns, we also need to achieve what we call as loose coupling. That is, changes made in one layer should not ideally impact another layer which depends on it. So loose coupling, technically speaking, in OO design is defined as a relationship where one object interacts with or communicates with or invokes methods on another object through the reference of an interface or an abstract base class, and is not aware of the implementation details of the invoked object. So what we want to do is we want to achieve a relationship where, let's say, if the UI layer has to talk to the business logic layer, it does so by talking to some interface exposed by the business logic layer and is not concerned with the internal implementation details, so that we can bring in a new implementation which exposes the same interface and replace the existing business logic as well. So to show that to you in a diagram, so look at something like this. Let's say between an end user and a database, we have our application, and our application consists of different types of logic. We have user interface logic, we have data access logic, we have the business logic, which is also known as the service layer, and we have data representation logic, logic needed to represent data of our business domain. And this usually tends to be kind of a horizontal or a vertical layer, that depends on how you orient the diagram, which cuts across all the other layers, because these classes which represent data would be used in all the other layers. So what I would like to do is I'd like to have each of these layers expose interface. For example, data access layer exposes an interface. This lollipop kind of a thing that you see in UML is how you represent an interface. So we want data access layer to expose an interface. Similarly, we would like service layer to expose an interface, and the UI layer should be dependent only on the interfaces exposed by service layer. The service layer should be dependent only on the interfaces exposed by the data access layer. So we don't want tight coupling between the concrete classes in these layers. Instead, concrete class in one layer depends only on the interface exposed by another layer. So if we want to replace a class in data access layer, for example, I could bring in a new class which implements the same existing interface, and the service layer should not even notice the difference that you have actually replaced an existing class with a new class. So I hope you get the idea behind what this application layering is and how we go about doing this application layering. When it comes to Java applications, these application layers manifest themselves as Java packages. It's very common to have Java packages represent different layers in an application. You can see, if you can focus on these package names, I have a package name ending with a .domain, which contains a class which represents the data of our hypothetical application. Let's say we want to deal with some customer information system, and to deal with this customer information system, we've created a class called customer. We are maintaining the ID, name, email, age of a customer. And this simple Pojo, an object of this class would represent one customer. If you think in terms of relational database table, one object of this class would represent one row in the table. So we'll see how to do that in future. But since this class represents the data of our domain, we have put it inside a separate layer or a separate package called domain. Similarly, I have a package ending with DAL or data access layer package. So this layer has all the classes and interfaces which help us load and store customer data from some form of database. So here we have gone in for interface implementation separation, and you can see we've created an interface called customer DAO, customer data access object. And this interface contains methods using which our business logic layer can store, load, and delete and do all sorts of other operations on customer data. Now, if you take a careful look at this interface, it has methods to deal with data in the form of objects. By looking merely at this interface, you cannot really know where data is being stored or how data is being stored, whether it's being stored in a database, whether it's being stored in file system, or it's just being stored in memory in some sort of a data structure. You can't figure that out by just looking at this interface. So that's the idea, that we want to hide the business logic from the details of where and how data is stored. So this interface exposes the operations that the data access layer would like to expose. Currently, we have provided only one implementation of this customer DAO interface. Since we are yet to discuss and see how to do RDBMS-based persistence and so on, we've created one implementation of this class called customer DAO in-memory implementation. And this class, instead of storing data in any kind of a database, simply stores all the customer data in an in-memory data structure in a hash map. So it just maintains a map of integer, that is the customer ID, versus the customer object. Whenever the service layer or the business logic calls save method to store a customer, it just increments the ID, which is an auto-incremented number. and sets that ID to the customer object and puts it in the map. Similarly, when find by ID is called, it just looks up that customer object based on the integer ID from the map and returns it. So this is just a placeholder implementation for now. Now in the service layer, which is the adjacent layer, so you can see we've created a class called customer service implementation, which implements an interface called customer service. So this customer service exposes all the methods that are needed by the UI layer. And we have really very minimal kind of business logic as of now. We have a method called add new customer. It just checks whether the name is not null before using the DAO to save it into the database. So this customer service implementation class in turn has a dependency on the DAO for all the data access operations. So you can see we are creating a reference of the interface type customer DAO. And although we are creating a reference of the type customer DAO, which is an interface, we can't really create an object of an interface. So we are creating, or we are forced to create, an object of the concrete implementation class. So we are kind of halfway to loose coupling because we are creating a reference of type interface, but our customer service implementation class is not truly loosely coupled from the implementation class of the data access layer because we're still having to instantiate the concrete class. So that is the problem that we're going to be solving very soon. So this is our service layer. Similarly, I have a UI layer, and this UI layer just has some keyboard-based UI, not a fancy GUI. And this UI layer in turn has dependency on the service layer. Again, notice I'm creating a reference of the type, the interface exposed by the service layer, but I can't create an object of the service layer. I can't create an object of the interface of the service layer. So therefore, I'm having to instantiate the concrete class in the service layer. So again, very similar to how it was in the service layer implementation class, we're kind of halfway there to true loose coupling because our UI layer class is still coupled to a concrete class from the service layer. And since this is the first layer, there is no adjacent layer which depends on this layer. I have not bothered to do interface implementation separation for this UI layer class. So therefore, the key thing to remember is that interface implementation separation is a necessary condition for loose coupling, but not a sufficient condition for loose coupling. We also have a main class which just ties all of these together, in which we are just creating an object of that that UI layer class and invoking one of its methods just to test whether all the layers are tied together or not. So I'm just going to run this so that we know what that means. So I'm just going to create a customer one, email abc@xyz.org, and 23 years of age. It says added customer with ID 1. So which means it went all the way from main to UI layer to service layer to data access layer and came back with the generated ID all the way back to the UI layer. So this is how we go about layering our application, but we haven't yet fully achieved loose coupling between these layers. We will be doing that in subsequent lessons.